Good evening, friends. Today, let us look at problem number 31 from Project Euler. It is the famous coin sums problem. What does the problem say? How many different ways are there to make 2 pounds using any number of coins in the given denomination? Now, pounds and pences are a way similar to rupees and paisas in India or dollars and cents in US or elsewhere. So for the easiness of vocabulary in the problem, let us treat pounds as rupees and pence as paisa. So what does the problem ask? The coins that are in circulation are 1 pice, 2 pice, 5 pice, 10 pice, 20 pice, 50 pice, 1 rupee, which is nothing but 100 pice, and 2 rupee, which is nothing but 200 pice. They have given one example or one possibility to make 2 pounds or 2 rupees in a particular way by taking 100 pice, which is a rupee, and taking 150 pice and couple of 20 pice and 1, 5, 2 and 3 will be able to make 200 pices or 200 pence or 2 pounds. The question is, how many different ways can 2 pounds or 2 rupees be made using any number of coins? So this is a very interesting problem. So let us go through this problem in this video. Now, where does the complexity of the problem lies? Let us try to make 200 pice using the coins that are in circulation. So how you can make? Let's start listing down the ways. You can take 1 200 paisas. Obviously, we can make 200 paisas by taking 1 200 paisas. We can take 200 paisas and make a 200 paisas or a 2 rupee. We can take 100 paisa and 250 paisa, making up 2 rupees. We could take 100 paisa, 150 paise, 220 and a 10 paise, again making up 200. Or you could take 100 and a 50, making up 150, plus a 20, 170, and 3 10 paisas, making a 200. Or you could take 100 paise, 50 paise, 150, and 20 paise, which is 170. And you could take a couple of 10 pice, taking it up to 190, and take a couple of 5 pice, which takes it up to 200 pice. Or you could take 100, 50, 20, and 210, one of the 5, 2 paisas, and 1 paisa. Or you could take 100, 50, 150, plus a 20, 170, plus 2 tens, 1 5, 1 2, and 3. You could just do the math. It will end up in 200 pice or 2 rupees. Now you know where this is going, right? So the complexity of the problem lies in listing down all the possible ways of how you could make 200 pice or 2 rupees using the coin denominations. So this is where listing down all the possible ways is where the complexity lies. So to get a hang, let us follow the useful and the powerful idea of computer science. Let us start with some very small cases. Let us ask the question, how can we make 1 paisa using 1 paisa? There is only one possible way. You take 1 of a 1 paisa and that's done. Now, how can we make 2 paisas using 2 paisas and 1 paisa? So you could take 1 of a 2 paisa, that's one possible way. You could take 2 1 paisas, that's another way. So totally there are 2 ways possible to make 2 paisas using 2 paisas and 1 paisa. Now, how can we make 5 paisas using 5 paisa, 2 paisa and 1 paisa? You could take 1 5 paisa, one possible way. Or you could take 2 2 paisas, making it up 4 paisas, and the remaining you could make it up with 1 paisa. Or you could take 1 2 paisas and the remaining 3 you can make it up with the 1 paisa. Or you could take 5 of the 1 paisas. So totally there are 4 possible ways to make 5 paisas using coin denominations 5 pice, 2 pice and 1 pice. So I think the small cases are giving us a hang of the problem. Now let's take the notch a little higher. Let's get our hands a little more dirty. How can we make 10 paisas using 10 pice, 5 pice, 2 pies and a 1 pies. So take one of the 10 pies. Yes, job done. That's the way. Take 2 of the 5 pies. That's possible. Or take 1 of the 5 pies and 2 of the 2 pies and 1 of the 1 pies, and it goes on. You could see it for yourself pausing the video. So there are 11 possible ways. Now let us ask, after playing with some small and pretty little big examples with our hand, do we see any pattern? What patterns do we see in this? If the denomination divides evenly into the target, that counts as one way. For example, 1 of 10 paisa makes directly the target. So the denomination divides directly into the target. So that's counting as one possible way. So 2 5 paisas also make 10 paisa. So that is one pattern we see. What is the other patterns we see? If the denomination, when dividing into the target, leaves a quotient greater than 1, right? So consider 2 5 paisas, right? When 5 paisas gets divided into the target, it leaves a quotient of 2. So the subsequent ways involves making the remaining amount using the remaining coins in the denomination list that is greater than the current denomination. So this, let's take an example and see the second pattern, because once we take a deeper look at the pattern 2, we would have solved this problem. So I'm just listing it out again what the pattern 2 was. If the denomination, when dividing into the target, leaves a quotient greater than 1, then subsequent ways involves making the remaining amount using the remaining coins in the denomination list that's greater than the current one which you are dealing with. So take that example, whatever I was telling before. When making 10 paisas using 5 paisas, 5 divides evenly into 10 with a quotient 2. So that's what it is making. 2 5 paisas make a 10 paisa. So now after 2 5 paisas, we can ask the following question. With 1 5 paisa, what is the remaining amount left out? With 1 5 paisas, the remaining amount to make is 5. And how can we make it using remaining denominations excluding that 5 paisa, because we have already made it. So how can we make the remaining amount, that is 5, using 2 paisas and 1 paisa? We have a recursion here. We really have a recursion here. First, we ask the question how we can make 10 paisas using 5, 2 and 1. But now we are asking the question how we can make 5 paisas using 2 paisas and 1 paisa. So I think you could spot the recursion, because we are asking the same question, calling the same function with a smaller value of the input until we reach the base case. So it goes like this. You try to make 10 paisas using 5 pies, 2 pies and 1 pies. So you start with 2 of the 5 pies, yes. Then you go with 1 5 pies plus count the number of ways to make remaining 5 pies using the remaining denomination, which is 2 and 1. So now the question asked is how can you make 5 pies using 2 and 1? Which leads us to, you could take 2 of the 2 pies plus remaining ways to make 1 pies using 1 pies. And now you are asking even more smaller question, how can you make 1 pies using 1 pies? This is only one possible way, plus number of ways to make remaining amount is 0, because after making 1 using 1 pies, the remaining amount is 0. So how many number of ways are there to make 0 using nothing? So how can you make 0 using nothing? 0 ways. So we have reached the base case. So this exactly is the base case of this recursive problem. And then this goes on. So after you finished with 2 pies, then you go with 1 2 pies and then count the number of ways to make the remaining. So from the 5, the remaining is 3 pies. How can you make 3 pies using 1 pies? And you pose the same problem How can you make 3 pies using 1 pies leads us to how many ways? So 1 into 3 pies plus number of ways to make 0 using nothing, which leads you to the base case. So that's exactly how we are going to attack this problem. So you could just take a look at this. You could look at this slide to get a hang of how the recursive call goes, or in the next slide I will show you a recursive call tree that makes this visualization even better. So we start with 5 pies. I want to count the number of ways I could make 5 pies using 5, 2 and 1. So first I start with 5 pies. So 1 into 5 pies. So the number of ways is 1 plus the remaining amount that I need to make is 5 minus 5, 0. So I'm calling the function again with how many, I want to make 0 pies with 2 pies and 1 pies. That makes a call. How could I make 0 with using 2 pies and 1 pies? So you could make 0. No, that's the base case. So that's return 0. So then you get 1 plus 0, right? So you have counted. There is one possible way. Now you go to the next denomination in the list. How could you make 5 pies using 2 pies? So 2 doesn't evenly divide into 5. So 2 into 2 pies plus what is the remaining? So 1 pies is remaining. Now how could you make 1 pies using 1 pies is the next recursive call. How could you make 1 pies using 1 pies? So you could make one way 1 pies into 1 pies and the remaining is 0. So now again call goes, the base case returns 0 and this returns another one possible way. And now the next iteration is instead of taking 2 pies, you take 2 pies. So remaining is 3 pies. So how many ways can you make 3 pies using 1 pies? So that makes another recursive call. How many ways can you make 3 pies using 1 pies? Which is one possible way, 3 into 1 pies. So when you make 3 using 1 pies, the remaining is 0 pies. So how many ways are there to make 0 using nothing? Yes, the next recursive call. That returns a 0. That returns 1 plus 0. So now finally, you go to the last one. So you have finished all the 2 pies. Now with 5, you could make one possible way. With 1 paise, you could make 5 in one possible way. Plus the remaining is 0. So how many ways can you make 0 using nothing is the next recursive call, which returns 0. So already there are 3 possible ways plus 1. So there are totally 4 possible ways. You could make 5 using 5, 2 and 1. So this is a simple recursive call tree for an input of trying to make 5 pies using 5 pies, 2 pies and 1 pies, and totally there are 4 ways which we saw above while working with our hand. So now what is the base case? Let us define the base case. If the target amount to make is 0 or the list of denominations is empty, then return 0. There is nothing to make, right? So there is 0 ways possible to make the target amount 0 or with empty denomination list. So that's the base case. So what is the inductive step or what is the recursive step? For each denomination in the list of denominations, find the quotient, target divided by the denom, and find the remainder. If the remainder is 0, which means the denomination that you are considering is evenly dividing into the target, and you get one possible way, right? So increment it. Then until the quotient becomes 0, right? What is the remaining amount to make? So the remaining amount to make is the target. You subtract the target from every possible combination of the quotient into the denomination. That's the remaining amount to make. So 2 5 pies you take, or 2 2 pies you take. So from 5 you take out 4. Then after you finish it, you take 1 2 pies. So from 5 you take 1 2 pies. Remaining is 3 pies, and finally 0. So that's the remaining amount to make, and the remaining denominations is list of all the denominations less than the current one. So this is the base case. This is the recursive step. Now total ways is the ways plus recursively called remaining amount to make with the remaining denominations. So this exactly is a simplistic way to recursively approach this coin sums problem. Now let us look at the code it exactly goes through this, right? We are having a simple class with a simple void main. So we are trying to make a target 5. I will go to the target 200 towards the end. So with target 5, and I'm just taking 3 possible coins in this for this particular instance. I want to make a target 5 using 5 pies, 2 pies, and 1 pies, right? So let's see what the call does, which is count ways. So we come here. So this is the amount that I want to make. This is the list of denomination. So here we have the base case. So we have counter. So the counter is going to be initialized with 0. So let us look at the base case. If the amount that I have to make is 0, or if my denominations is empty, then I'm just returning the count. Here is the recursive step, the else block. So what do we do in the recursive step? So starting from the first denomination till we finish up all the denominations, we find the quotient. So the quotient is amount to make divided by that particular denomination. And the remainder is exactly the same with the modulus operator. Now, if the remainder is 0, then the number of ways is incremented by 1 because you have found one way to make the amount using that particular denomination. After this, you start your inner loop. So in the inner loop, you start with the quotient and you iterate that inner loop until the quotient becomes 1 or reaches 0. Right? So now you compute the remaining amount. So the remaining amount is nothing but the amount that you want to make. You take that difference from the quotient into that particular denominations of I, right? So if it is 5 and 2 into 2, first you will get 5 minus 2 into 2, right? Which is remaining amount to make is 1. And you construct another array which is going to be the remaining denominations. So there is an easier way to pull out the remaining denominations because already the denominations are in the order of the coins in circulation. So if it is Python, you will be using a slice notation or something. Even in Java, there is a particular implementation. So here I'm just going with a simple imperative way to fill these remaining denominations. So I'm just creating an empty array, and as long as the empty array is in the last element, the remaining denominations is going to be null. Else, we just need the remaining denominations to be of the size less than the current one to hold it, and we just fill the remaining denominations used from the current plus 1, like displacing every single element. So this is nothing but the way how we are filling the remaining denominations. Just nothing complicated there. So you compute the remaining amount to make and you compute the remaining denominations. And once you do this, then you are just going to increment the count by calling the same function recursively by saying how much is the remaining amount that I want to make using the remaining denominations. And this loop is going to run, and you will every time the remaining amount to make is leaning towards 0 because you are taking out, and the remaining denominations is becoming empty. So always this case will converge at 0 or null denominations and the function will terminate. So the base case is guaranteed to converge while the recursive step is making it move towards the base case. So at the end of it, once you have finished through all the denominations that are there, you are returning the count. So you could just draw out the recursive call tree for yourself and then just count it with a small example. So here, let's take the first example, which is trying to make 5 using 5, 2, and 1, and we should be getting 4 possible ways. So let's just try to run it. So here I'm just trying to run it, and we are getting the number of ways to make 5 using 5 pies, 2 pies, and 1 pies is 4 possible ways. So I will just comment this out now, and let's go with what the problem is asking, right? So the problem is asking how the target to make is 200 pies using the 8 different coins in circulation: 200, 100, 50, 20, 10, 5, 2, and 1. And I'm just going to call the same function recursively so until I make the target using the denominations. Let us compile this once again because we changed the target and the denomination list, and we run this. Let's run this. So we want to make 200 pies using the 8 different coins in circulation in the United Kingdom. The total number of ways that are possible is 73,682. Totally there are 73,682 ways to make that 200 pies or 2 rupees or 2 pounds using the 8 coins in circulation. I hope you enjoyed the problem and you enjoy the recursive way to model this problem and solve it. I will see you in a next video with an interesting problem next time. Thank you.